algebra students. Today we're going to talk about factoring, and specifically we're going to be talking about factoring out a GCF, or the greatest common factor. You've used greatest common factor probably in elementary school when you were looking for the biggest number that would go into something, into a list of numbers. We use them in particular when we're simplifying fractions. So we would want to be able to find the number that we could divide the numerator and denominator by and find the biggest number that we could do that with. So today what we're looking at is looking at different monomials and trying to find the greatest common factor that we could take out of each of them. Now, if I would just list the common factor, I'm sorry, not just the common factors, all of the factors of 15 and 30. I'm not going to do this when we have other variables, but if I have 15 and 30, the numbers that go into 15 would be 1, 3, 5, and 15. Those are the only numbers that go into 15. In 30, I could have 1, 2, 3, 4 doesn't go in there, but 5 does, and so does 6. And then 7, 8, 9 don't, but 10 does. Not 11, 12, 13, 14, here's 15, and then 30 is the next one. By the way, a trick for this is this was a pair that multiplied. Each of these are pairs that multiply to be 30. Now, if I'm looking for the greatest common factor, the biggest number that's in both lists, that's going to be 15. Right? 15 is the biggest number that I could use in both of those as a factor, something that I can be dividing by. So if I gave you a fraction like 15 over 30, you could divide both numbers by 15, and that would be the fastest way to simplify it. When I look at a problem like number 2, I have variables involved as well. So I'm not going to make a list of all the different possible combinations, but realize that I can take out things that are in common, but I can't take out more than what we have in one of the two terms or monomials that we're looking at. If I look at just the numbers, 14 and 21, the biggest number that goes into both of those would be a 7. The other stuff that we have in common, so I can see that this first term has some k's. Well, the second term doesn't have any k's, so there wouldn't be anything in common there. Greatest common factor is what we're looking for. So then I would look at my j's. I have a j squared, or 2 j's that are getting multiplied together in that first term, but only 1 j in the second term. I could factor out, I could divide out a j from each of those terms, but I couldn't take out a j squared because that second term didn't have a j squared, it only had a single j. So 7j would be my greatest common factor. Looking at 3 and 4, they look very similar. 3 just doesn't have coefficients, it doesn't have any numbers out in front. So if I look at the k's that I have in all 3 terms in number 3, they all have some k's, but the smallest number that I have, k squared, that's going to be my greatest number of k's that I can take out, because I can't take out more than that. I don't have any more than that in that last term. For the m's, they all have some m's, but again, the one that has the least number of m's is this one. There's only 1 m in each of those. So k squared m would be the greatest common factor. That's the most that I could take out that would be the same in all 3 terms. Notice we're not even doing any of the division yet. We're not factoring that out. I'm just finding the greatest common factor. Number 4 has exactly the same variable parts. I know it's going to be k squared m, but when I look at my numbers, I have a 21 and a 15 and a 5. The biggest number that can go into all of those is actually just a 1. There's no other number that goes into each of them. Now, if this last one hadn't been here, just looking at the 21 and the 15, oh, I could divide both of those by 3. That'd be fine. But because I can't just get rid of one of these, when I'm looking at 21, 15, and 5, again, 1 is the biggest number that can go into all of those, So I already know my variables. K squared was the best I could do for my K's. Regular M is all I could do for the M's. I could put a 1 in front of here, I suppose, but it doesn't do anything. I would have the same greatest common factor in number 4 as I did in number 3. Now I want to find the greatest common factor and I want to factor it out. This is really just a reverse distribution. That's all it is. I'm just trying to find the biggest thing that I can take out of each thing. So looking at number 5, just the number parts, 36 and 64, thinking about numbers that go into both of those. If you need to make a list, if you're not as comfortable with common factors and doing that divisibility in your head, for 36, again, you can certainly make a list. And maybe it's easier to not make a list all in order for you. If you wanted to say, well, that'd be 1 times 36, and 2 times 18, and 3 times 12, and 4 times 9, and 6 times 6. For 64, I know that's 8 times 8, but let's find all these other ones. So 1 times 64, 2 times 32, 3 doesn't go in there, but 4 does. 4 times 16, and 5, 6, 7, and it'd be 8 times 8. Out of all this list of everything, ignore the multiplications. Find the biggest number that goes into both of these. And that number is going to be 4. I have a 4 here and a 4 here. That's my biggest number part that I can take out of both. Then when I look at the variables don't match at all. So what I'm going to do really is I'm going to just reverse distribute. I'm going to factor out the GCF. I'm going to divide everything by 4. 36x squared divided by 4 would be 9x squared. 64, y to the 4th divided by 4 would be 16 y to the 4th. By the way, all of this mess right here, totally not necessary. If you can do that in your head and find the biggest number, you don't really need to make a list of all of the numbers. That's just one way to do that. Looking at number 6, what number could go into 3 and 27 and 9? The biggest number that can go into all of those is a 3. And they all do have a common variable. They all have x's. This one only has a regular x, so all I can take out is just a single x. So now remember, I am dividing each term, each piece, by 3x. So 3 divided by 3 would be a 1. X cubed, and I'm going to take out one of those x's. I'm left with an x squared. By the way, if you want to check to make sure you did that right, multiply them. 3x times x squared, yep, that's 3x cubed. Then 27 divided by 3 would be 9. I had an x squared. I'm going to take out an x. There's one x left. 9 divided by 3 is 3. There was an x. I factored it out. It's done. Again, feel free to distribute that and make sure that you get the same answer that you started with. But that's how we factor out a greatest common factor. Number 7 doesn't even have any numbers. You can see the variable parts of 7 and 8 are exactly the same. So when I look at this, there's no numbers to take out, but they all have x's. I could take out a single x. When I do that, when I divide an x, I would have x squared left for the first term. I would have a regular x for the second term. And then don't fall into the trap that a lot of people do. They said, oh, x divided by x, that's just gone, and then they stop here. That's wrong, because I still need a trinomial there. I need to have something almost like a placeholder so that when I would distribute that x back in, I would still end up with an x as that last term. X divided by x is actually 1. And then when I check that with the distribution, this would be x cubed, this would be x squared, and this would be a regular x. So we already know the variable part of number 8. The numbers, I have a 4 and a 2 and a 2. I could factor a 2 out of everything and an x out of everything. So again, this is a division. 4x cubed divided by 2x. 4 divided by 2 is 2. I had x cubed. I take out one of the x's. I'm left with x squared. 2x squared divided by 2x. 2 divided by 2 is a 1. and x squared divided by x, there'd be 1x left. And 2x divided by 2x would be 1. In number 9, the 15, the 9, and the 6, the number part that I could take out of all of those, that's not a 6, because 6 doesn't go into 15, but 3 goes into all of those parts. And all of the variables are different in this problem. That means I can't take out any variables at all. All I'm going to do is just divide everything by 3. So I'd be left with a 5a and a 4b and a 2c. The 3 can't just go away. This isn't an equation. I'm not dividing both sides by something. The 3 still has to be in my problem. And make sure that if you would distribute it, that you would get back to your original problem that you had. In number 10, the number that can go into 8 and 18 would be 2. The variables don't have anything in common, so I'm just going to divide everything by 2. So 8x squared divided by 2 would be 4x squared. Plus a negative, or just minus, I suppose, 8y squared divided by 2 would be a 9y squared. By the way, if you factor something out and you're not sure if you got the greatest common factor, when you're done, look at what's in the parentheses. If you notice that there's something else you could divide everything by, besides 1, then you didn't get out the greatest common factor, so you might have to go back and retry it. Number 11, I don't have a coefficient on the first term, so I can't have a number part of my GCF. And the second term doesn't have any x's. The only thing that's in common in both of these is a y. So when I factor out, when I divide out that y, x squared y divided by y would just be x squared, right? And if I would distribute, that would give me x squared y. 2y divided by y would just be 2. And again, if I would distribute there, that would be 2y. In number 12, I could take out z's from both of these, but not just a single z. This time, I could take out a z squared because the second term has a z squared. Everything has at least 2 z's in there. So I'm going to take out a z squared. Z cubed divided by z squared, there would be just that one z left. And 4z squared divided by z squared would be 4. For number 13, the number that can go into 64 and 56 and 8, all of those can be divided by 8. And in fact, they all have the same variable also. I could factor out a c in each of these. So 64c cubed divided by 8c. 64 divided by 8 is 8. I had a c cubed. I took out one of the c's. I'm left with c squared. Again, plus a negative could just change into a subtraction. 56 divided by 8 would be 7. I had a c squared. I factor out a c. I'm left with a c. 8c divided by 8c. Again, this is where I worry that some people are just going to say, oh, it just goes away. But 8c divided by 8c is really 1. Number 14. They all have 33s. We're going to be able to factor out a 33. And they all have q's. They don't all have r's, but we do have q's in all of them. However, I only have this single q right here, so that's the most that I can take out. So 33q cubed divided by 33q. Well, 33 divided by 33, that's 1. I had a q cubed. I'm going to take out one of those, so I'll have a q squared. 33 divided by 33 is a 1 again. I had a q squared. I'm going to take out a q. There's one q left. And there was an r. And 33 divided by 33, 1. Q divided by q, 1. R squared is left. Again, because that first term didn't have an r, I can't do any more than this. That's the best that I can do. On these last two problems, 15 has a's and b's. So I only have a single a right here. So that's all I can take out for a's. The b's, the smallest number that I have right here is a b squared. So if I take out one of the a's and two of the b's, I would be left with a squared. right? Check it with multiplying if you need to. I have an A in the middle term. I have an A cubed. I'm going to take out one of them. I'll have 2 left. I have B to the 4th. I'm going to take out 2 of them. I have a B squared. Then, in the last term, I had an A. Take it out. It's gone. B to the 4th. Take out 2 of those B's. I'm left with a B squared. And for the last problem, 18, 8, and 2. I'm sorry, 18, 4, and 2. 2 is the biggest number that can go into all of those. They don't all have K's because this middle term doesn't have any K's at all. Do they all have X's? Yep, they all have a single X. I can take that out. Do they all have Y's? Yep, they all have a single Y. So from the 18, KXY, 18 divided by 2 is 9. The K is going to stay, but the X and the Y both get factored out. 4xy divided by 2xy is just going to be a 2. And the 2 divided by 2 in the last term, that's a 1. I'll have k squared. The x and the y both get factored out. Sorry for the bell, but today there is a worksheet. Factor out the GCF worksheet, the answer keys in Schoology, and then make sure that you take the formative in Schoology when you're done. If you have any questions, let me know.